Good afternoon, everyone.
Great.
Dear Dr. Abdul Wahab Zayed, Secretary General of the Khalifa International Award for Date Palm and Agriculture Innovation, distinguished guests from inside and outside the UAE, respected media representatives, we are delighted and honored to meet you today in the 9th Scientific Virtual Lecture organized by the Khalifa International Awards for Date Palm and Agriculture Innovation in its 2020 Scientific Knowledge Sharing Program. And now I would like to welcome the Award Secretary General, Dr. Abdul Wahab Zayed, to give his welcoming note. Dr. Zayed, the floor is yours, please.
Thank you, Ms. Sarah.
Thank you.
Good evening, dear respected Excellency, distinguished guest, researcher, scientist, date palm growers and producers, dear colleague, Dr. Jose Romano Falero. I am very delighted to meet all of you today through this weekly virtual platform. And I'm honored to start the 9th scientific lecture, which comes under the directives of His Highness Sheikh Nahyan Mubarak Al Nahyan, Minister of Tolerance and Coexistence, President of the Award Board of Trustees, and also within the Awards 2020 Activities and Events Program. We are very pleased to welcome Dr. Jose Romano Falero, the international expert specialized in red palm weevil from the Republic of India and one of the FAO's experts, who will be presenting today a scientific lecture entitled Red Palm Weevil, Past, Present, and Future. Wishing everyone a fruitful time and hoping to see you in our coming events and lectures. Thank you. Dr. Falero, the floor is yours.
Thank you, sir. I am delighted and honored to be doing this presentation. I wish to profusely thank Khalifa International, Professor Zaid and his colleagues at the Secretariat of Khalifa International Award for Date Palm and Agricultural Innovation. I'm extremely delighted to be with you in the next 1 hour or so. As mentioned by Professor Zaid, I will be doing an overview on red palm weevil, talking about the past in little, the present where we are, and vistas for the future. So, can I start my presentation?
Yes, please, Doctor.
Okay.
Please share your screen.
Okay. Can you see it?
No, we can't see it until now. Just make sure you're clicking on the green button beneath, underneath the screen.
Dr. Falero, you have to enlarge the screen to see the icons on the bottom. There is a green one that says share screen.
Yeah, I did click on that, but I don't know what happened.
It's not coming out.
Okay, I will rejoin.
Okay.
Just in a second.
Okay.
Yeah, I clicked on the screen and here my presentation.
We still can't see it, Doctor.
Share.
Yes, now I think it's opening. Yeah, we can see it now. Just enlarging
Okay.
the screen
you.
from down. If you-
Yes,
it's possible to presentation mode.
yes. Is
Yeah.
it okay?
Yes, perfect.
Thank you so much. Sorry for this little inconvenience. And again, I'm delighted and honored to do this presentation, especially during the year of International Plant Health. Excellent opportunity to be with Khalifa International once again and speak about red palm weevil, which is such an important pest the world over. Red palm weevil is one of the cousins of the Rhynchophorus group. There are about 10 weevils, the Rhynchophorus weevils, worldwide in different regions of the world. But red palm weevil, Rhynchophorus ferruginus, is probably the most notorious, followed by Rhynchophorus palmarum in South America on oil palm. Its global spread has been tremendous. It has captured almost all the ecological regions of the world, except the temperate cold region where you don't find red palm weevil. And the predictions are it will still spread further. We do not have red palm weevil, Rhynchophorus ferruginus, in South America. It's absent as of today, but the predictions are if the quarantine regulations are not followed, it will appear there soon. The recent European Plant Protection Organization report shows that red palm weevil is in about 50 countries, 49 countries to be precise. The most recent being Bulgaria, Bosnia in southeastern Europe, Bulgaria in the Black Sea Basin, and Russia. Russia has come on board. You know, Russia was having this pest for quite a few years, but no one reported this. And of late, in the last 2 years, it has been reported, and it moved to Abkhazia from Russia. There were some other reports also, like Papua New Guinea, Solomon Islands. They have withdrawn red palm weevil from their list. Australia has withdrawn. They have the cousins, Rhynchophorus vulneratus, but not Rhynchophorus ferruginus. Similarly, USA, 2010, there was a big report saying that red palm weevil is in the US. Everyone was wondering, but later in 2013 molecular studies, they revealed that no, we don't have ferruginus, we have vulneratus. Red palm weevil, as you know, has invaded some of the most pretty, beautiful, pristine, ecologically heritage sites all over the world. From Al-Hasa, where I spent quite a time of my life in Al-Hasa working on red palm weevil, to Tangier in Morocco, another beautiful place, Elche, Spain, Siwa in Egypt, where Khalifa International has done so much of work in Siwa. All these beautiful places red palm weevil has invaded in the last 15 to 20 years. The latest, as I told you, is Russia and the Black Sea Basin countries, and Djibouti in East Africa, 2018 report coming out of Djibouti. As the country range expanded, the host range also expanded. In the 1956, mid-1950s, you had just 4 palms: coconut palm, Phoenix dactylifera, date palm, Metroloxen sagu, and Caryophylla amarylifera. Just these 4 palms were the host of red palm weevil. But today, it is reported on 40 palm species worldwide. So if anyone is importing any palm, please be careful. Do a proper quarantine audit before you really want to import something or export something to another country, a palm. Which are the top 3 palm species preferred? Phoenix canariensis, much preferred, followed by Phoenix dactylifera, date palm, and coconut, where it was traditionally existing for so many years. Right through the Middle East and the Arab world, you see date palm grown profusely in monoculture settings. And this is particularly true in the last 20 years or so. Rapid expansion of date palm. So red palm weevil on date palm attacks young palms less than 20 years. An estimate suggests that there are 50 million palms in the susceptible age group in the NENA region. This is a huge challenge for the countries. and for everyone alike to combat this pest and deal with it. Check escape routes of RPW. We have quarantine regulation. Each country has very good quarantine regulations, but probably when it comes to implementation, we lag behind. Some countries lack proper quarantine protocols. This is a truck moving from one country into another country in the GCC region, carrying date palms. And whenever there is a big event, Sochi Olympics, Russia, 2014, they brought in Phoenix canariensis, they brought in red palm weevil. Similarly, any big event happening, the World Cup, now in Qatar has the World Cup, they have gone in for large landscaping. I was fortunate to visit Qatar a couple of years ago. The moment I got out of the airport, the old airport, I saw Phoenix canariensis. So I was wondering, when you have date palm, why do you need Phoenix canariensis? No, it's our fascination for palms, to bring exotic palms. But when we bring exotic palms, we are bringing red palm weevil with it. Then the offshoots are moving indiscriminately. Weak enforcement. The rules are there, regulations are there, but enforcement is very weak. The EU, European Union, has some well-defined guidelines. They look at delimitation of the area, survey and demarcate the areas, 3 monthly official inspection, annual crop declaration, application of phytosanitary treatments in the nurseries, in the hotspots, registration of planting material for movement, and use of plant passports to monitor the trade. These are broad guidelines. Each country could develop their own guidelines. This comes from Egypt. You see this field here is a field with a tractor, and there is nothing there. You can see some palms, probably if you look carefully, about a kilometer or 2 kilometers away. And you see red palm weevil here. From where this pest has come? How did it come? Who brought it there? We don't understand the ecology and behavior of this pest. So that is the major reason why we are not able to control it very well. It is totally hidden. All the life stages are inside. The only life stage that flies out is the adult, partially hidden, partially flying. And when it flies out, we deal with it with insecticide. We want to spray, or we want to trap it. These are the two logical things that we do. It's highly aggregated. Its behavior, one of the behavior is, if I have a heavily infested garden, my neighbor will get the infestation. It moves in groups, in clusters, one cluster to another cluster. This is in Tunis, in Tunisia. The national park there, right in Tunis, you see the headless palms of Phoenix canariensis, all aggregated in nature, clumped. The seasonal behavior. During the summer, you get 2 peaks, one during March, April, May, and the other during November. But the November peak is better because the larvae are caught in the winter. The eggs are caught in the winter. They do not hatch. But these adults that lay eggs, they result in infestation. There are several predisposing factors, from neglected garden to trimming of the fronds, removal of offshoots. When we remove offshoots, when we trim this, we create wounds. So they instantly attract the pest. And if we do not treat the wounds, eggs are laid. Now, this is not always that it will lay eggs only on wounds. It will lay eggs in any hidden sites in the offshoots. This is a cut male palm. We often cut male palms and leave that like that. This becomes a breeding site. If we could just pour a little diesel in this would help. This is a closed garden, right in the GCC. In most of the GCC countries, you will face this closed garden problem. Many of the gardens are closed. Now, some of the countries have come up with regulations. They put a notice on your board. If Bob Sucker, they say, okay, we will cut your electricity and we'll cut your water if you don't report within a week. So the door will open automatically. After a week, the door will open if someone is inside. Then, see, this is Saudi Arabia, flood irrigation. Flood irrigation for date palm, it is not very good. Especially when the water touches the stem, it attracts red palm weevil. Now, damage and detection and IPM. We have to know the damage symptoms. These are the damage symptoms. You see the juice coming out from cut fronds, if these were cut and they were not treated. You see white aerial offshoots from far away. This is 100% red palm weevil. If you go in the base, you will find red palm weevil. This is the frond. Very difficult to detect. These symptoms are not enough. You have to have an experience to detect an infestation. This is of no use. This is, anyone will say this is infested. This is in Portugal, in Lisbon. This is right here in Goa, in my state, in coconut. And this is in Saudi Arabia. Date palm, coconut, Phoenix canariensis. These are gone cases. This has to be removed. So these are the early symptoms, but very difficult to get them. In Phoenix canariensis, you have a series of symptoms. Just the first 3 stages: perforated fronds, chewed fronds, and frond wilting. If you catch it at this stage, you may be able to save the palm. Once asymmetry starts, crown asymmetry, partially collapsed crown, no new fronds, umbrella stage, this is the end. You cannot recover such palms. 1, 2, 3. Symptom number 1, symptom number 2, symptom number 3. If you are in symptom number 4, your task is difficult. Symptom number 5, you might as well cut the palm and take it home or eradicate it. So early detection is the key to the success of red palm weevil control. This is in Italy, where this is umbrella stage. This is of no use. So much of devastation. Now here comes the loss. What is the loss? There is no figure put on the loss as such, but it runs into millions of dollars. Each country, when we see country reports, they say the losses are enormous. They have not quantified. None of the countries have sort of done a study on the economics, but it runs into millions of dollars of the loss itself. And then the control measures are also very expensive. To replace these palms now, it's also an expensive affair. So what is the IPM strategy? The IPM strategy, this was published by FAO, and it is divided into 4 stages. Stage 1, stage 2, stage 3, stage 4. Stage 1 is day-to-day operations. If you are in operations doing area-wide control, you will be dealing with stage 1. Stage 2, the government will come in. Quarantine regulations, quarantine protocols, the government plays a role. Stage 3 is supportive. You will support the IPM above. Stage 4, training, workshops, IPM field days, extension, all supporting the program. So stage 1, the moment you have red palm weevil, you will either go for detection, or trapping in any order. You may start trapping first, or you may start manual visual detection. Chemical treatments, both curative and preventive, removal of severely infested palms, and then validation. Many of the countries don't do validation properly. Validation is lacking. Some IPM program is going on. Some traps are there, some insecticide is being sprayed, eradication or removal of severely infested palms is happening. But no, people, sort of don't sit back and analyze data, because huge quantity of data is released in area-wide operations. So this is in day-to-day operations, and one has to give a very clear thought about the operations. I will show you exemplary cases of the Canary Islands where they use GIS and things like that to do proper validation of the program. People talk about resistance, host plant resistance. Date palm has a wonderful genetic diversity. Reports say there could be as many as 5,000 species, 5,000 varieties. A beautiful genetic diversity, but none of it is so far exploited for control of red palm weevil per se. The varieties that we like, red palm weevil also likes. You want class in the GCC countries, red palm weevil is highly susceptible to, class is highly susceptible to red palm weevil. You go for Sukkari, red palm weevil likes Sukkari. You go for maybe Deglet Nur in North Africa, red palm weevil would like Deglet Nur. So resistance is to be exploited. Frond and offshoot management is of very great importance. When you remove the fronds and remove the offshoots, please treat the sides. Water, excessive flooding, this is not to be done. Palm density, irregular spacing. We try to overplant. This is not very good. Poor field sanitation. These are some of the predisposing factors. Now, when it comes to detection, there are many detecting aids that are being researched upon, but most of it is being done is visual. Today we have detecting of chemical signatures. There are papers to say, chemical signatures of red palm weevil can be detected. Acoustic detection, sound detection is most advanced. From Mankin in Saudi Arabia to Cast, Hassan Al-Aid in Saudi Arabia, acoustic detection is moving ahead. So probably we'll get a good acoustic detector. Optic fiber detection, basically principle is acoustic detection. Infrared cameras, thermal imaging, very costly things, very costly. So detection, the good detection device should be efficient, should be easy to use, and should be low cost. These are some of the detectors. This is a sound detecting device. Dogs are being used. I know of one farm in Saudi Arabia that has used dogs very effectively. Abdul Latif Jamil. Huge plantation in Saudi Arabia, Al Ghasim. They are using dogs and visual infestation. This sensor-based detection, this was from Egypt, but did not work. This is some other type of detector, but really did not take off. This is the recent AgriNet detector. It's cloud-based. Their information is put to the cloud. They put a bismar, a nail in every palm. Doesn't look to be very practical and could be very costly. And interpretation, who will interpret this? You will have to hire someone to interpret this data. The farmer should be able to interpret it. That's the time that the detector will be useful. So here, this is Saudi Arabia, the engineer going with a screwdriver, for visual detection. Very experienced engineer, he will be able to detect infestation. This is in the Canary Islands, visual detection. So visual detection is the one that is practiced widely. And here I was fortunate in Saudi Arabia during the FAO program. We were testing repellents, and suddenly there was a report that the infestation is very high. So we stopped our repellent work, and the infestation was 7%, 80 palms infested in a garden of 30 hectares. Out of 3,000 palms, 270 infested. Within a month, the Mudriya brought it down to 1%. Just by visual inspection. And then every month they kept checking. And within a year, less than a year, they brought it to almost negligible. But I have put a danger sign here. This is the inoculation that will take off again if we do not look at this. So visual inspection once a month or once in 45 days, we say now. Saudi Arabia is practicing it. It's very good. Next is trapping. The most common thing we say is put one trap. Trapping is the first thing we want to do. And these traps, they have the pheromone and the host attractants. Now this trap can be a double-edged sword. If you don't follow the right protocols, the insect can go on the tree. What is the history of trapping? These are the traps, these are the lures, this is the food bait, ethyl acetate, trap density. There are papers to say you put 10 traps per hectare, but is it possible to put 10 traps per hectare? Operationally, it is not. If you are doing operations as a farm manager, you cannot put 10 traps per hectare. No one can. So you go with 1 trap per hectare and then go for dry trapping systems. Especially in these COVID times, when the labor cannot be accessed, labor doesn't go to the field, social distancing, the best thing would be is to have your trap and go for bait-free trapping. You have now in the UAE this elect trap, which you don't have to service. This is also very good. But the ultimate trap would be one that is smart, that is giving you data and that does not need servicing. People are working on this type of a trap. Trapping just accounts for about 40% of the population. The remaining population is there. This was an olfactometer study we did at King Faisal in Saudi Arabia. And that there we saw that just about 35 to 40% comes to the traps. The remaining doesn't. So that's why trapping itself will not help. This is in Libya, FAO mission 2010 in Tobruk. You see, they did only trapping and nothing else. They had 10 weevils per trap per month, and this reached up to 100 weevils per trap per month. In May 2009 into February 2010, within 7 months, they got 10 times increase in the captures. That's because they were doing nothing else, only trapping. Whereas Morocco was combining trapping with detecting, with treating, with eradicating, and their trap captures remained at 2 to 5 weevils per trap per month. They could not eradicate it, but they suppressed it. How many traps you put? Wherever we go, they ask how many traps we put. We start with 1 trap per hectare, and if the density increase, you increase the traps. Trapping is population dependent. So if the population is high, you go for higher trapping. But higher trapping is not practical, and therefore, this is what happens. If you put more traps, you can't service them. So this will be counterproductive. This is very bad. The moment you see dubab, flies in your trap, you know this trap is not serviced for at least a month. So what do? You go for serviceless trapping options, which is attract and kill, dry traps, and repellents. Repellents is not very well developed, but I'll come to it. This is a dry trap that originated from Italy and has its base in the UAE. And it's quite good. I saw it in Jordan. We saw it in Saudi Arabia. We tested it. It's quite good. It does not need servicing. It's a dry trap. Now, the principles on which it's working, the company claims it is electromagnetic radiation. But there is a group in the Costa Rican group has said no. It is that it does not prevent escapes. It prevents escapes. So that's why it's working. This is the study we did in Saudi Arabia. These traps, the standard Saudi trap and the Pikusan trap, they need servicing. Whereas the no servicing, the elect trap is a dry trap, no servicing. So your people need not go to the field to record observations. Once a month, yes. Ultimate trap, as I just mentioned, would be with one that is smart. CAST is working on it in Saudi Arabia. Through the coming FAO project, they plan to take it further. They make it smart. They make the dry trap smart. You get data through satellite directly on your laptop. Early morning you come, you open your laptop, you know, okay, there is a red palm weevil in Abu Dhabi, this place. There is red palm weevil, Abu Dhabi, that place. Trap number 10, trap number 5, okay. But we have to use this data. Having data on the laptop or in our book will not be enough. This is dry trapping. You just put a spot. This cannot be put on one tree. It has to be put on all the trees. So the question asked is, there are millions of palms. Do you put on all the million palms? No. You put only where the infestation is high. In neglected gardens where you cannot go. This was another dry trapping system, but it is not very efficient. So we deleted it. This spot you see, this is the spot you leave on the tree. There are two companies that make this. One is Smart Ferrolure and one is Hook W. One is USA, one is Costa Rica. Both are equally effective. I tested it even here in India. This was in Al Ghasir, where you had dead weevils on the ground. But the ministry wanted evidence. So when it came to evidence, we put the spots in containers. I call them containers, not traps. At 5% of the points. 5% of the points in 4 months, 24 weeks, captured 111 weevils. This is in Al-Khaj in 6 hectares. So yes, in this garden, you require attract and kill. You require to increase the trapping density. Whereas in the garden B, farm B, it captured only 7 weevils. 5% points captured 7 weevils. So it does not make economic sense to use attract and kill here. So attract and kill has to be used selectively, and based on your trap data, based on your infestation data, you go in for attract and kill. And I would re-emphasize, COVID times, this is an excellent tool to use in the field. Sometimes due to the private contractors, they are unable to service the trap because they don't get laborers or their orders are not issued. Just do attract and kill. It will work. Where do you do it? In neglected plantations, in mazras that you cannot enter. This is in Mauritania, FAO project in Mauritania. We used attract and kill there as one of the components. It worked wonderfully. Repellents. You use repellents to push the insect away and give protection, especially in organic gardens. We identified a group of repellents, and in the FAO project, we tested it for palm protection, but the data was inconclusive. We need to repeat the data, repeat the trial. This is the theory. You put repellents in the center and traps on the border. So push-pull, you develop a push-pull strategy. But you have to put numbers on this. This is a theory. There are no numbers, there's no paper. This has to be worked out. Chemical treatments. Are we spraying too much? Are we? So much of insecticide is being used. Are preventive sprays really required? Preventives, you can manage your garden without preventive sprays, I believe. Now, this is in Phoenix canariensis, where they put a tube and allow insecticide right on the top. In Phoenix canariensis, probably it is okay because the infestation is on the crown. But in date palm, so much of spraying is probably not required. This is when you remove the offshoots and the fronds. Yes, this is the time you require spraying. This is in the Canary Islands, where they have to spray the crown, periodically spray the crown. Very expensive, very laborious. Which are the insecticides? These are the range of insecticides. You have a group of insecticides, better to rotate the insecticides in different treatments for the crown, for the frond treatment, or for a soil drainage. This is curative treatment of an infested palm. You drill and push insecticide in. In a simple way. This was in Egypt, where they made holes, the farmer made holes, and through a can, he delivered insecticide. It diffused inside and it got controlled perfectly well. Now here, in some places, they removed the tissue excessively. This is more the damage than what the red palm weevil did. In some countries, they damaged the tissue due to excess pressure during palm injectors, using palm injectors. Are these palm injectors really required? I saw in Egypt, where the frond has died. This is the frond here. It has died due to excess pressure. So using a pressure machine has to be done very carefully. Should not exceed 2 bar. You can recover palms that are in the early stage of attack. This is in Tunis, where the Canary Island palm, you see the sprout coming again. Izala, removing the palms, eradicating the palms. This is another big, laborious, expensive process. Pulverizers, taking the palm to another site. But now what FAO is saying, if you open FAO guidelines, it is clearly written there that you only eradicate the infested part. The other part, you keep it there. Don't take it anywhere. Just let it be there. You cut your cost and you do justice to the whole program. Burning, this burning also is not recommended, because inside it remains as it is. And the moment you cut the palm, you have to pour some insecticide. So what is being said now, what FAO recommends is you remove only the part that is infested. The remaining part, let it be there. No need of removing the whole palm. When you remove and transport the palm, you be very careful. I'm showing it for canariensis, but this principle also is true for date palm, where you have to shift the infested portion to another side. You have to fully enclose it and shift it. If you're going to take it open, you will have insects flying out and infesting your gardens on the way. Biological control, much spoken of. Every seminar we meet, they talk of biological control. Practically, this is difficult to exploit in the field. But now in the FAO program on research, this is being given priority. There were 2 good papers on semi-field assays saying that nematodes and Beauveria bassiana formulations work to some extent in the field. Semi-field assays. Periodic validation. Here you are. You did everything, you did trapping, you did detection, you did curative treatment, preventive treatment. Do you validate your program? You sit every week with your engineers, or every month, or every 15 days and validate? For validation, you need a map. You need to know where you are. This was a map in 1997, a simple, when there was no GIS, no nothing. This was a hand-drawn map. Every day we used to plot the trap captures on the map. And end of the month, we would get a beautiful diagram. You don't have to, say, I don't have GIS, I don't have GPS. You sit with a map, you make a map of your own. Hand draw a map and plot the trap captures on it every week. This will give you a beautiful map. Your manager will know, your supervisors will know where you are working, what is the situation. You can divert your resources from one place to another. This is 300 hectares, mind you, Al Suhaimiya. 30,000 palms, about 270 hectares, 1997, before GPS came. Then, in the Canary Islands, they started using GPS, data collection, transmission, interpretation, decision making. This formed a core of their control program, and it gave quite good results. They developed a effective mobile application. Now, FAO has developed a mobile application called Susa Hamra, which is used for data collection, transmission, and interpretation. This was a plain GIS map of the trap captures during spring, during summer. During spring, 2009, this area was bad as compared to 2010. But in the summer, there was an improvement, more yellow. And if you see annually, the 2009 looked better than 2010. So this is for project managers or even for supervisors to see where they are when they need to divert their resources, need to divert their funds to the areas or the hotspots where it is most required. FAO is developing a Susa Hamra mobile application where they are planning a regional collaboration. A data platform, a unified platform will be available where data will be transmitted through Susa Hamra mobile application for infestation, for trap captures. These are the two major parameters. And of course, other parameters like curative treatments, removals of palms, etc. Success stories coming out the Canary Islands and Mauritania. What did they do? Canary Islands did delineation, inspection, intensive guided inspection, eradication of infested palms. They did not treat any infested palms. They did trapping, they did cultural practices, they did legislation. They did not allow, it was an island situation, so probably a bit easy. They did not allow any imports into the island. Continuous training, awareness and extension, risk evaluation. This is where you have to sit down with your team as a manager and evaluate. Control the movement of planting material even within the island. The manager was telling us that once the municipality wanted to plant palms, there is a clash between the municipality and the Directorate of Agriculture. Municipality wants to do beautification and brings palms, infested palms and plants. So there has to be a cooperation between the municipality and the Directorate of Agriculture. And they use GIS. What did we do in Mauritania? Inspection, of course, Mauritania was a very small area, but infestation starts in everywhere in small proportion. They did inspection, they did trapping and attract and kill, eradication of all infested palms. They did not treat any palm. Strict quarantine measures. Treatment of wounds. Any wound after removing the frond, they treated it. Prohibited offshoot removal. For some time, the farmers cooperated and they said, we will not remove the offshoots. For a year, they did it. They went on intensive training, participation of the farmers in the program. This is probably lacking in the GCC countries. Farmers don't participate in the GCC. The state provides everything. Proactive extension farming, extension campaigning. These were some of the major parameters that helped Mauritania gain full control or eradicate red palm weevil. May 2020, they were supposed to declare that they have eradicated red palm weevil. Now, the UN had a high-level meeting in 2017 in Rome. Several countries, several organizations, NGOs, scientists, private sector participated, reaffirmed their commitment to lead national, regional, and global efforts to combat red palm weevil. The meeting agreed on a framework strategy for eradication of red palm weevil and supported the establishment of a trust fund to implement the strategy, which is currently being implemented from Egypt, regional headquarters in Cairo. So two programs basically, one for the NINA region where you have the key outputs of governance, monitoring, scientific research. This is being developed now by FAO, capacity building and coordination. And the global platform for data collection, georeference data, monitoring, early warning systems, mobile app for data collection, online system and data analysis. Huge data is released every day in Red Palm Weevil area-wide control programs. So the SUSA Hamra app. So what are our next priorities as far as research is going to be? Early detection tools, efficient, should be efficient, easy to use, cost effective. Quarantine protocols. We do not have quarantine protocols for landscape palms and even for the offshoots. We need easy quarantine protocols. Dipping in insecticide and all becomes very cumbersome. Biological control. There are good biological control agents, but delivery and sustenance, this is a problem. New semiochemical mediated technologies like push-pull involving repellents and attractants, attract and kill that we just discussed, attract and infect, biological control. You attract it in the trap and infect it with a Baviera or nematodes and let it go and infect the other population. Understanding the bioecology of the pest. Impact of preventive insecticide applications. I would like to emphasize, we are over depending on insecticides, and our dates, especially from the NINA region, should not get a bad reputation of excessive use of insecticide because these are very harmful. Then using molecular techniques for actual practical control. There are huge number of papers, advanced, high peer-reviewed journals, but they just remain in the journal. There is nothing much that is delivered in the field as far as molecular biology goes today. So this is all I have to say, and I hope I was effective in conveying the message. I wish to thank FAO, the organizations that I worked in the past, the Ministry of Environment, Water and Agriculture, Kingdom of Saudi Arabia, King Faisal University in Al-Hassa, and the Indian Council of Agricultural Research. Over the last 20-30 years, I've been involved with these organizations. Thank you very much.
Thank you so much, Dr. Valerio. Now we can welcome any questions to Dr. Valerio, if any of the participants. Does anyone have any questions? Please raise your electronic hand so we can.
I tried, but it didn't work. Can I ask a question?
Yes, please.
Thank you, Dr. Valero, for this very interesting and also very technical presentation. As you know, we work together in Saudi Arabia with our colleague, Dr. Abdullah bin Abdullah. We've been involved in this program, and through the project we've been implementing in Saudi Arabia. And also there are so many projects and programs implemented around the world. Here you talked mostly about the technical issues, but as someone, as an expert who is involved in this issue of red palm weevil for years, I have a question, and I would like to know, how do you evaluate the IPM programs implemented by different countries, international organizations to control red palm weevil? We've seen so many strategies, so many conferences, technical meetings, etc., but still the pest is spreading and the situation is worsening. The sanitary situation is worse. This is one. Second, I've seen that you are talking about the Bovaria bassiana is then again coming in. And as you know, this have been the subject, Bovaria, nematodes, etc. This have been the subject of a large regional program in the Gulf area implemented by AOAD and financed by IIID. I personally participated with Dr. Zaid and other colleagues in Al Ain to discuss the outcome of this program. And we've seen that at the end we came out that it didn't help because people, they were working in laboratories, they were putting their fungi in optimal situations, and then
Yeah.
it was normal that it killed and then it infected the pest. But in the field, issues are
Exactly.
different, you know. And when working in the laboratory, you put it in 25 degrees with 90% humidity, etc. While in the field, you are at 45, 50 degrees, 30% of humidity, etc. Then it's very dry. It's not. Then it didn't work in the field. This I'm really surprised that we are coming back to it. And also, just to find the last things is about the success stories. The stories or success stories you listed, as you said yourself, this is in very limited area. In Canary Island is also isolated areas, but these issues, these programs, and all this, what we have used, we've been in Saudi Arabia, and you saw the Saudi Arabia that has used huge materials, equipment, and etc. Still, the situation is something like this. It will never work. For example, in Al Hassa, where you have 2 million date palms. Thank you.
Regarding evaluation of the program, Dr. Wahhabi, two criteria that can be used vigorously to evaluate. One is the trap captures. Provided the traps are good. Now, if you have a bad trap, you will not get any SUSA. You will not get any insect, and you will say, my program is good. I've seen in some countries, I won't name the country, they said, our trap captures are coming down. So when we saw the pheromone they were using, they had changed the pheromone. They were evaluating against a weaker pheromone. So they were getting lower catches. So under a standard protocol, you have to evaluate your program. This is number one. Second is infestation reports also help. But what we see is infestation reports, some of the engineers go and come back and say, everything is okay. There is no problem. There's nothing in the field. One fine day, the whole tree falls down. So infestation reports are a bit dicey to depend on. So if you have a good trapping program, this is the number one criteria to judge your whole program. On a broader scale, over a period of time, how the captures have come down. This is the way to evaluate the whole program. And we have developed, it was through the FAO program only during the first mission in 2008 with Dr. Ben Abdullah and all, a sequential sampling program, wherein we see in a sample size of 100, what is the infestation, whether it is 1% or less than 1%. That is a sequential sampling plan that can be used to assess your program. These are the basic criteria, and now you have GIS, things like that, which also help.
Yeah. Now we have Mr. Mustafa. I think he has a question for Dr.
Yes, Sarah, may I also answer about biological control? I am in complete agreement with Dr. Wahhabi. This biological control is not that good. It doesn't work. And the AOAD program and all has clearly shown that it does not work. But we still see papers coming up about biological control off and on. So Dr. Wahhabi, I am totally agreement with you about biological control. But what happened in Bari is some researchers said that it is very effective and it works very well. So then they said, okay, we give you a last chance. Let us test it properly. We define a protocol and we say what are the parameters. ICARDA was supposed to lead this program. But let's see how it goes. Once and for all, we want an answer, yes or no. Does biological control work or it does not work?
Okay, Mr. Mustafa, I think you can go ahead now.
Yes, thank you very much. This is Dr. Mustafa Echid from Morocco. Thank you very much, Dr. Falero, for this beautiful and concise presentation. Very, very interesting for us in Morocco, since we had that problem since a few years ago, and we really need to control it. Thank you very much also to Khalifa International for organizing such very interesting conferences. My questions are in three parts. My first question is about the acoustic detection and any early detection. Could you please tell us, Dr. Falero, what is the best detection, early detection available today? Because as you know, in Morocco, it's still, the red palm weevil is still on the north, which is to deal with Canariensis.
Yes.
But imagine if this insect goes to the oasis in south, that would be terrible for us.
Disaster.
So I would like to know if you can tell us in a very concise way what is the best one available today. That's the first question.
As of now, Dr. Mustafa, there is no really very effective. See, I believe that the principles of a good detector is efficiency, number one.
Yes.
Ease of use. Tomorrow you say, I have a detector where it is transmitting data to the cloud, and the cloud will send data to your laptop and all these things, and you need to hire someone to interpret the data. This is not a detection system. I don't believe in this. The detector has to be in your hand.
So the visual one is today is the best thing. Is the visual
is the only one that is working practically. But there are groups that are working on this hand detector, acoustic detectors that can be used with the hand. And it may come very soon. It may come. You give it about a year or so. I think we will have something from Riyadh or CAST. There's something may come. But where you say, IoT, what is that? Internet of Things and all this cloud-based, and this is a very difficult issue. As it is, red palm weevil control is complicated. We don't need to make it more complicated.
Okay.
Satellite, it comes via satellite and all this very high tech. This is not practical. So visual is the only thing that will help. 45-day cycle. We recommend a 45-day cycle. Saudi Arabia is implementing this visual observation. A bit costly, but effective if you have a good manpower. See that your manpower does not leave you.
Yes. How about the smart traps? Since if you put enough smart traps together with visual observations, are these smart traps actually effective today? Are they really working? And what is the situation?
Yeah, Dr. Mustafa, the smart trap only transmits data. So the servicing part, see, the elect trap is dry.
Yes.
It captures, it is dry, it is not smart. Yes. So if you make the dry trap smart, that is a real smart trap. So today
is it available in the market today?
No. I have just read the reference last week. Some Rinco Foss or someone in Spain, I can send you the reference, that they have made the Picusan trap smart. Picusan trap, but the Picusan trap needs to be serviced. Picusan trap needs food. So if you're going to put food, anyway, there is no real smart trap as such. The elect trap is quite good, but you have to have your normal trap also to get the data.
Are you aware of that smart trap developed in Holland? I don't know where it is.
Maybe Holland. Yeah, I will send you this reference. I don't remember it right now. It's commercially available, and I will send you. But when I read Picusan trap made smart, that is only half the story. Picusan trap needs servicing. Picusan trap, you have to put food inside.
Yes.
So if you're going to put food, you might as well get the data every week. You don't need data every second. You're not going to run to your field. If you get data now, you're not going to run to your field. You can wait for a week.
Okay. Last question, just to leave the floor for other people to intervene. About endotherapy. I mean, I know you don't like too much endotherapy, especially if it's a high pressure. It should be under 2 bars. But there are other systems used in Spain that looks quite good. What do you think about these systems?
Yes, there are good systems. I agree, but it should be under technical supervision.
Okay.
If properly trained people can do it, it's very good.
Thank you very much.
Thank you. And now we have Dr. Ashraf Al-Far. I think you have a question for Dr. Falero.
Yes, hello everybody and good evening for everybody. First of all, I'd like to thank Dr. Jose for a nice and very informative presentation. And many thanks for Khalifa International Order for this series of virtual presentation, which really benefit all of us. Actually, my question to Dr. Jose about the biological control, because the red palm weevil, it looks like we have to live with it. It is impossible to eradicate, to eliminate, and whatever we do actually, we have to live with it. The biological control, I heard about some article about using of bacillus, a very special kind of bacillus for killing or for eradicating the red palm weevil. Actually, this is used to put some of this organism bacteria as a bacteria antagonist in some of the date palm. Actually, it helps a lot in eradicating some of these species in the early stage. Have you heard about it, and have you do some research about using of such bacillus bacteria as an antagonist against the red palm weevil?
Per se, I have never worked on biological control. This is one component I have never worked on. And there are reports about bacillus, against red palm weevil coming from India way back. I think from Egypt also there are reports about bacillus. But you see, doctor, any technology will just take off. If this thing is working, I think it is a wonderful thing. We all want this. We want a good biological control agent. Right from the time that, we started our program in 1993, someone came with tiger nematode from USA. This tiger nematode, when you put it in the tree with the SUSA, it will work. When the moment the insect is deep inside the tree, it does not work. So it depends, these papers, I tell you, these papers are sometimes deceptive. They pour the bacillus on the insect they release inside, and they all have died. Whether it is gone right inside the meristem, inside the xylem phloem, whether that bacillus can reach, that is to be seen. I make a hole, I put some SUSA inside, and I pour bacillus. It will die, and then I come back and I write a paper. The field work I tried in the field, it has worked very well.
Yeah.
So let us give it some time. At least I have not heard of this bacillus thing.
Thank you so much, Dr. Ashraf. Now we would like to give the floor to Dr. Abdul Wahab Zayed, please.
Thank you, Ms. Sarah. Usually I keep my brief intervention at the end, but to make this conference more fruitful, well, first, let's thank Dr. Falero for his excellent presentation. I'm always pleased with his valuable input as an expert, but also as a lecturer and so on. So thank you again on behalf of Khalifa Award. I think to make it more fruitful, there are other, we are lucky, of course, to have the best experts in the world in regard to different disciplines. We have, I'm not going to cite everybody, but you have Dr. Abdul Basit, you have Dr. Wahabi, Dr. Abdullah bin Abdullah, so many people in different fields. But in this pest issue, I am pleased to see, I hope he's with us now, Dr. Al-Buhsini. He used to be with ICARDA, and he worked a lot in the ICARDA program in the GCC and other countries in regard to the red palm weevil. So I want to, if possible, Ms. Sarah, to give him a few words. Also, we have Dr. Walid Kaka. He's also a pest control expert, and he did write several manuscripts and books in this regard. We do have also our dear Michel Ferry. I can see him, he's also connected. So if we could ask kindly these people, these honorable experts to give us 1 or 2 minutes, about the subject, so everybody will be beneficial. But again, I do highly second what has been said by our dear colleague, Dr. Falero, in regard to the best detection technique and eradication and so on, mostly to answer our dear friends, Dr. Mustafa Aitshit. I have 2 countries that I leave the case with, is Sultanate of Oman and Israel. Both of them have been infested, and both of them control the situation by visual examinations and eradication. So those two models should be well followed for these modern plantations wherever they are. So the floor is Ms. Sarah, if possible, to Dr. Bouhsini, Dr. Walid Kaka, and Mr. Michel Ferry. Thank you.
Thank you. So now we can welcome Dr. Bouhsini, if you can hear us. Okay, I think now we can go with Dr. Abdullah bin Abdullah. I think you have a question first.
Hello, hello.
Hello.
Hello, Dr. Falero. Thank you for this presentation. It's a pleasure to see you again and to meet you through our honorable award, Khalifa International Award. My question, because I can see and we are afraid about the south of Tunisia for this red palm weevil. We are still struggling in the north to control this insect. I think what I know and through all what we work together in Saudi Arabia is that the important thing in this fight against red palm weevil is the management. But unfortunately, this is the weak thing we have in all, most of our countries to fight against red palm weevil. I don't know. I just want to have your opinion about the control in Tunisia, if you are informed, of course. But I can tell you it's still going from governorate to another in the north.
Dr. Abdullah, so nice to see you again. And this is a dangerous situation. When we met in Tunis 2 years ago, we had put up a proposal on what should be done. And the great fear is of even your train that moves from Tunis to the south, that this insect could hitchhike on the train and go to the south. So this is a possibility. And for that, monitoring to whatever extent possible, capacity building, and quarantine. These are the three pillars where red palm weevil does not exist. Monitoring. Now, the next question is whether we should put traps or should not put traps. We have decided that you put traps in a particular season and remove them. Don't keep them there throughout. And move the traps, because you can get a wider area, you can get a grasp of a wider area. If that could be done. Phytosanitary treatments do not allow any planting material to move without certification. This is the number one requirement, because a lot of nurseries taking Phoenix canariensis and other palms from the north to the south to all the oases, this can create a problem. I would like to emphasize the success in Sudan. They have implemented, they don't permit transport of offshoot from one oasis to another. When Dr. Zaid sent me there to Sudan, this is what we saw, which was very nice. From one oasis to another, there is a mamnu, there is a ban on the transport of offshoots. So your offshoot, you use it in your oasis only. Don't take it from south to another oasis, your relative living somewhere. No, this is all stopped. Nurseries have to be managed very well. Most of the cities have nurseries. I see it here in India. I see it everywhere. In all the countries. We were in Jordan, in Amman. So many nurseries, palm nurseries. So they are also responsible for transmitting this pest. And of course, capacity building for the farmers, to the agriculture officers, to all the stakeholders.
Thank you so much. So now we can welcome Dr. Bouhseni. Floor is yours, please.
Well, thank you so much, Dr. Zaid, and thank you so much for the Khalifa Award for this opportunity. Of course, I'd like to thank my friend, Dr. Falero, for the wonderful presentation he gave. As usual, he's an excellent speaker. I usually enjoy his talks. And now, let me just comment on the biological control aspect. Of course, there were problems with biocontrols probably during the, I would say, last 10 years, 15 years or so, when that big project was implemented in the Gulf by OWADA, I guess. But we cannot claim, we cannot continue, repeating the same thing, oh, it failed. No, but the technologies have changed. I mean, the science has really, has been developed. Now there are excellent formulations. We don't do business as usual. We don't do business the way we did it years ago. So I believe, I don't think we should really close the door for science, because to me, that would be wrong. We should give, in fact, Dr. Falero knows, and some of the colleagues know, we did put together a big proposal, several experts on biological control, led by ICARDA, and to this FAO initiative, still pending because the funding is an issue. They did not get much really to cover all the different technical groups, the different proposals. But I think, in my opinion, I don't think we should just say, well, no, don't do this, don't do that. Let me just give you, I mean, I don't know whether the time allows. I was in Central Asia one time, and then I talked to an entomologist in Kazakhstan, and he told me, he gave me a gift, and that was a book on insect entomology. That was about probably 10 years ago. And then he said, Mustafa, what do you do? I said, well, among the things I work on is host-plant resistance. He said, what, are you dreaming? Host-plant genetic resistance for insect crops, to resist to crops? Are you dreaming? Believe me, he stopped discussing with me. And people know we have released varieties carrying insect resistance in several crops. Not only us at ICARDA, but a lot of other organizations. So all what I'm saying, should never close the door for an option, a management option, and say, no, it does not work, and khalas. And that's really wrong. So for instance, the example of host-plant resistance, Dr. Falero pointed to that, of course, should be given a chance. I'm sure host-plant resistance with the huge diversity of the, I'm sure there must be resistance out there that we should really tackle it scientifically. Also, landscape management should not have only, I mean, I sometimes I really feel frustrated when I go to a farm, a date palm farm, and it's very clean. That's very wrong. That's not good. Does not help the natural enemies. You have to allow some landscape, some other crops, etc., so that you have flowers for the natural enemies. Otherwise, you cannot conserve beneficial insects. You cannot have biocontrol working. I'm usually against this mass rearing of predator parasitoid. I don't favor that, but I do favor landscape ecology, landscape management, having diversity in the cropping system so that you favor natural enemies. This I would like to stop and thank you again, Dr. Zaid, for the supporting. Thank you. Thanks, of course, to the Khalifa Award. And of course, by the way, I'm still with ICARDA until probably December of this year, and then I retire, inshallah. Thank you so much.
Thank you.
Miss Sarah.
Thank you so much, Dr. Bouhseni. And now we can, if we can allow Dr. Walid Kaka, the floor is yours. Dr.
Hello,
Walid?
assalamu alaikum.
Yes.
Can you hear me?
Yes.
Yes.
Hello, Dr. Valero. It's really a nice presentation. It's educational one. I just want to have two comments. One related to the pheromone traps, the number of pheromone traps per hectare. In the UAE, we use actually 2 traps per hectare as far as mass trapping. I believe it's, if we are going to consider it for monitoring or for mass trapping. For monitoring, probably 1 or 2 traps per hectare probably was going to be enough for monitoring. But for mass trapping, many programs, they do not really follow the correct number. The correct number should be at least 4 or 5 traps per hectare. I know it's a labor consuming because you are going to use more laborers to monitor or to inspect the traps on a weekly basis. That's if you are going to use traditional traps, the one which you are going to add water and food on a weekly basis to inspect it. The maintenance, it's a weekly inspection during the summertime. Probably it's a bi-weekly, probably during the winter time. But I believe that 1 trap per hectare for monitoring probably is going to be acceptable. But for mass trapping, we need more than that. In the UAE, we use 2. And in certain areas, really, we need really 3 or 4 minimum per hectare. Maintenance is really the main components of the pheromone systems. If there is no maintenance, if you are going to only maintain the traps on a monthly basis, we are going to really lose many adults, or catching will be really reduced. The second comment related to the detection tools. For me, I have evaluated the many tools, and the best one as far as the pheromone traps is really the Electrap. I have evaluated that in 2015 and into the last 5 years. In the last 5 years, I have evaluated the Electrap many times, and I believe I'm the first one who evaluated the Electraps in the UAE. And we used it for 4 months. We haven't really added any, of course, it's a dry trap. And really, we went there on a monthly basis just to check the catch, but it's really a very good tool. But again, I agree with you 100%. Visual observations is the best for me. So we can really combine the visual observations plus the dry traps will be really good to catch the red palm weevil adults. Thank you.
Thank you so much, Dr. Walid. And now we would like to invite Dr. Michel, if you could hear us. Dr. Michel. I think there's something wrong with the sound with Dr. Michel because we cannot hear you. And now we can welcome any more questions. Okay. I would like again to remind all the honorable participants to provide us with your contact details so we can update you with all the awards news or further information on the awards categories or participation in the International Library. So please, it would be much appreciated if we can have your full name, email, and phone number in the chat down here. And also we would like to thank you so much for your attendance today, and we are looking forward to meeting you again on the 8th of November in the second session of the awards target categories for potential candidates. So we're looking forward to on seeing you again on the 8th, as we said, which will be Sunday, 8 p.m., 8th of November. Thank you so much, everyone. Thank you, Dr. Valerio. for
Thank you
your
very much.
valuable lecture.
Thank you.
Thank you, Dr. Abdulwahab Zaid. Thanks to all the honorable attendees and participants. Wishing you a great night and looking forward to see you soon. Thank you.
Thank you.